Hi everyone. Section 0.16 is on variation, which uses a lot of terminology from physics. So, this model, y equals k times x, this indicates that y is directly proportional to x, or y varies directly as x. Y equals k times x, where k is some non-zero constant of proportionality, or variation. That's a lot of words. Here's a basic example. Tipping. Now, if you're Steve Buscemi in Reservoir Dogs, you don't tip, but k equals 0. But let's say that you tip 15%. I've had servers who said 20%, 25%, 30%. But let's say you tip 15%, okay? Then k equals 0.15, where x is the value of your meal and y is the actual tip that you give the server. So your tip as a dollar amount is directly proportional to the value of your meal. Y is inversely proportional to x, or y varies inversely as x, if and only if y equals k divided by x for some non-zero constant k. Z is jointly proportional to x and y, or z varies jointly as x and y, if and only if z equals kxy for some non-zero constant k. It's like a double multiplication. Okay, example. H is directly proportional to V and is inversely proportional to the square of R. And first of all, we can find a general model where we write this as a single equation. In fact, let's do that right now. Let's write down the general model. H is directly proportional to V. That means H can be described as K times V and is inversely proportional to the square of R. It's assumed that we write this all in a single formula, a single equation, and is inversely proportional to the square of R squared. By the way, this notion of inverse square laws, you see a lot in physics in the context of gravitation, electromagnetism. For example, let's say that you have a light source here. Here's a light source. It's a beaming light source. Hopefully not the sun. You're not supposed to stand too close to the sun. But let's say that you are here. You're standing pretty close to this light source, this lamp or whatever, right? And let's say that your friend over here, is standing 3 times as far as you are from the light source. Now, is your friend getting 1/3 of the light intensity? No, it's an inverse square law. Your friend is getting 1/3 squared, or 1/9 of the light intensity. So inverse square laws are things that you see a lot of in physics. Anyway, now that's the general model, but we can find the value for k, which we often have to do. We have to find the actual value of this constant of proportionality if we're given particular data. Find the particular mathematical model related to this statement, that is, find k, okay, if h is 2, when v is 18 pi, and r is 3. So what do? We take the general model, plug in these values, and solve for k. Let's do that. We plug in h equals 2, v equals 18 pi, right? H equals 2, v equals 18 pi, and r equals 3. Don't forget to square the 3. We have r squared down there. And then you solve for k. You can do it in different ways. For example, you might note that 3 squared is 9, all right? 18 divided by 9 is 2. So we have 2 equals 2 pi k. We want to solve for k. So what do? Don't say move. say divide by 2 pi. Divide by 2 pi on both sides. K alone is on the right side. We have 2 over 2 pi here. How can we reduce this? Boom, boom. So do we get pi over there? No, it's 1 over pi. That's why I like to put ones. The parentheses might be overkill, but at least put a 1 up there. K is 1 over pi. So we have our constant of proportionality. We're not done yet. It's like finding B in that line problem. We have to plug this into the general model that we got way up here. K is 1 over pi. Plug that in and simplify if necessary. So we take this general model, plug in 1 over pi for K. But we don't like this because it's a compound or complex fraction. Let's multiply by pi over pi. We're multiplying by 1 creatively in such a way that we're going to get rid of that little denominator there. 1 over pi times pi is 1. We still have the v up there. And then the pi down here moves over with the r squared. So we get h equals v over pi r squared. If you want to be cute, you can multiply both sides by pi r squared. Turn it around. What formula is this? I hope you remember. V equals pi r squared h. Pi r squared, that's the area of a circle times the height, volume of a right circular cylinder with base radius r for that circle down there and height h. I was being cute. Not all of my formulas or equations will be that significant though.